Today we're talking about compound events, in particular using tree diagrams. So if we wanted to make a list of possible outfits, this would be our sample space. We have shirt 1, shirt 2, shirt 3, pant 1, and pant 2. So the way that we would make an outfit is with shirt 1, we could wear either of these pairs of pants. We could wear pant 1 or pant 2. With shirt 2, we could make, again, the same combination with pant 1 and pant 2. Same with shirt 3. There's only 2 options of pants, pant 1 and pant 2. So from there, we know that shirt 1 with pant 1, shirt 1 with pant 2, and so on and so forth. These 6 options are what we would be able to say are our possible outfits. Make sure that you have this written down. Okay, so what would happen if we then introduced this shirt and we added in the dress pants? Okay, so now we have 4 shirts and we have 3 pairs of pants. So let's take our original options. We have 4 shirts now, so let's add in shirt 4 with the pant 1, the pant 2, which means we would have 8 total options if we had only 4 shirts and 2 pairs of pants. But adding in this 3rd pair of pants, we would have a new line added to each one of these. So shirt 1 with pant 3, and so on and so forth. So if we look here, we have 3, 6, 9, 12 total options if we have another shirt and another pair of pants. Okay, so that shows us all the options. If they would ask you to list the options, this would be the best way to do it. If they asked you how many options you would have, we could literally just take 4 times 3 and get our 12 options. All right, you try this one. A sandwich cart offers 3 types of bread, 2 types of meat, and 2 types of drinks. Make a tree diagram to count the number of possible sandwich drink combinations. Okay, I'll be back in just a second to show you the answer. Make sure you start with your bread first. So bread 1, bread 2, bread 3, and then go from there. Okay, let's make our tree diagram. All right, so here's what I would have done. You start with your breads. I'm going to show you in each different color. So here would be the meats, and then for the drinks, let's do that in red. We would have, again, 2 options, and then, so let's look at each and every option that we have. So with bread 1 and meat 1, we have drink 1 and drink 2. With bread 1 and meat 2, we have drink 1, and we also have drink 2. So if you look here, there are 12 possible combinations. You don't have to write all of these down. I'd rather you focus on the tree diagram part, but notice that there are 12 options. All right, you have a plum, a banana, an apple, an orange, and a pear. If you eat one now with lunch and eat one later for a snack, what are all the possible pairs of fruit you can select for lunch and a snack? So let's abbreviate them: plum, banana, orange, pear, apple, like this. Okay, so if we look at these, I could eat a plum now, I could eat a banana, an orange, a pear, or an apple for my snack. So with the pear, there are 4 options. I could eat a banana then for lunch, and I could eat the plum, the orange, the pear, or the apple for a snack. Again, 4 options. I could eat the orange and have the plum, the banana, the pear, or the apple. Another 4 options. I could eat the pear and have the plum, the banana, the orange, or the apple. And I could eat the apple and have the plum, the banana, the orange, or the pear. So again, there are 4 options for each. So if I eat one of the 5 now for lunch, I have 5 options. But after I eat one, how many do I still have left for my snack? I only have 4 options. So 5 times 4 is 20. That can tell you how many options you have. So if you look here, these are my options. This tells me the number. There's a difference. If I ask you for what are the possible pairs, I want to see the tree diagram. If I want to know how many possible pairs, then you can use this method. Make a tree diagram to find the number of possible outcomes involving a number cube and a coin. This is called a compound event. It's when we have 2 or more simple events. So if we rolled a number cube first, that's what they want us to do. We could get 1 through 6. Okay? Think about that and see if you can make your own tree diagram. Okay, I'm going to show you what I did, but make sure that you have your own first. Will you please correct it in red? If you get it all right, go ahead and put a star next to it using red, or any color, even a marker would do, or a highlighter. So if we look here, we could roll a 1 and get heads or tails, roll a 2, same thing, 3, 4, 5, and 6. So there are 12 total options, and these are those options. 1 with heads, 1 with tails, 2 with heads, 2 with tails, and so on and so forth. Even if we tossed the coin first and we did heads versus tails, and then we spun this spinner, heads would have 5 options, tails would have 5 options. Okay, so when we look here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have a total of 10 possible options or possible outcomes. And the way we could figure this out if we didn't need to show the sample space would be 2 times 5. Okay, suppose you toss a quarter, a dime, and a nickel. Find the sample space and figure out the probability of getting all 3 tails. Let's look at this one. So if we toss a quarter, a dime, and a nickel, there would be 2, 4, 6, 8 options. So if we want to get all 3 tails, it would happen 1 out of every 8 times. Remember, this is probability, the number of options that we desire to have versus the total that we actually have. So these are the favorable outcomes over the total outcomes. If we look at this one, an animal shelter has both male and female puppies. So we've got a male and a female. They come in yellow, brown, or black. We call these golden, right, sometimes. So yellow, brown, or black. If we look here, we have 6 total options. So out of 6, what is the probability of choosing a female that is yellow? So we're looking for female and yellow, so 1 out of 6. I want you to try this one. Read it, and I'll be back in just a second to go through the answer. Make sure that you correct it with a red pen when you're done, or any highlight or anything. Okay, you should have paused the video, so here's what I would do. I made my tree diagram facing this way this time. Door number 1 with blue, yellow, red, 2, same thing, 3, the same thing. So what's the probability that the prize is in the blue or yellow box behind door number 2? So here's the blue, here's the yellow. There are a total of 9 possible outcomes, and 2 of them are favorable. So 2/9. And that's all I have for you today. I'll see you next time.